Okay, so now that we have our player movement working pretty well, let's set up our cameras and lights. First thing I want to do is change the positioning of this directional light, and I want to rotate it down some because it's kind of throwing a shadow that doesn't make my game look great. So I'm going to take that, I'm going to set it to about 60, and that's going to look quite a bit better. And you can see if I move in on the sphere a little bit by hitting F, and I click away, you can see that that lighting system is quite a bit better. So now if I click play on the game, you can see that if I move around a little bit, that the camera's in an awful position relative to the sphere at all times, and it doesn't really help with our gameplay. So I'm going to stop the gameplay for a minute, and we're going to adjust the camera. So first we want to move the camera to a new set of coordinates. So I'm going to click on the main camera, and we're going to start this main camera off at, let's see, we will go to, let's actually just move it up 10, and we will rotate it down, and I'll scroll out so we can actually see the camera here. Move this way so we can see what the camera is actually doing. So you can see it can't even see the sphere right now, so we'll rotate it down about 45 degrees. And that gives us a pretty good angle on the sphere and where it's going. And you can try it from a couple of different locations in different directions, but for now this works pretty well. So now we need to set this up so that the camera kind of moves around with the object. So you don't want the camera to be in a fixed space, because as the ball moves back, you can't see it as well, and as it moves forward you might be able to lose it. So here I could conceivably, let's start this over, and if I'm looking at this from the right view, it'll be easier to tell. So let's say I click play here and I'm moving this ball this way. I could get out of the view of the camera, and my ball could actually fall off the board as it's done here, and we'll try that again. You can see once my ball goes off camera, it can fall right off the board here, and I wouldn't even be able to see it. So that's not a good thing. We want the camera to move around with our player sphere. So normally what we do in like a first-person shooter, if I were making a first-person shooter, I would just take this main camera and I would make it a child of the player object by dragging the main camera on top of the player object. And then as I moved around, the camera would move with the player. But it doesn't produce the desired results if we do this in this particular situation. So if I go forward, you can see that my camera is going completely nuts. And the reason that that's happening is because this ball, as it's moving across the plane, it's rolling. And when I make the main camera a child of the player, it actually rotates with the player as well. So it takes all the movement. So we're not able to use just a simple parent-child relationship to handle the camera movement here. We're going to actually have to add a script for it. So let's click on the script folder, and I will create, actually instead of doing it that way, let's select our main camera object, and let's go ahead and add a component to it. And let's see if I can move this down far enough, and we will add a new script, and we will call it camera controller, and it's going to be in C#. So we'll just click create and add, and so now that's added directly to the main camera, which is what we wanted for it. And now I can just take this camera controller script and I'll drag it into the scripts folder, and everything is great. So now I'm going to double click the camera controller to open it up in MonoDevelop, and it opens up right to my camera controller. And now I'm going to create two instance variables. One is going to be a public game object, and it's going to hold the value of our player. And then I'm also going to create a private instance variable that holds a vector3 value. And we'll call that one offset. And in the start, so as we are building the initial program, as we're initializing it, we want to set offset equal to the difference between the position of our camera minus the position of our player. So transform.position returns the coordinate values of the object. So our if we just write transform.position without referencing it in any other way, it will assume that we mean the transform position of the current object or the object that this script is attached to, in which case it would be the transform position of the camera. So we're going to take the transform position of the camera and subtract it from the transform position of our player object, and that is going to, and we're going to maintain that offset position as the camera moves around. So we're going to set the camera up to move with the player object, but we're going to keep the same offset. In other words, we're going to keep the camera at the same distance and angle from the player that we did before, and that's what this offset variable is there to do. Then in update, we're going to actually change that to late update. And what late update does, it calculates every frame just like regular update does, except for it waits till everything else in the frame is done first. So this is the last thing to get calculated in the frame. So my offset and all the other movement of the player object is done first before I calculate. So I make sure that the player object's completely done moving before I update the position of the camera, and that's a good thing. So now I'm going to set the transform. Now instead of setting something equal to the transform position, I'm actually going to change the transform position of my camera to the player transform position plus the offset. So I'm basically telling the camera move with the player but maintain that same offset position. So let's save that and go back into Unity. And then now back in Unity, remember that we set up the public variable for the player game object. And remember with the player object, we were able to set and modify the value of that public variable, and we can see that here. We could change that speed variable to 6, and we could adjust it right in the editor. Well, this is the same for every public variable, but in this particular case, we are able to, we have a public variable for the player object. And the way we handle that, instead of setting a numerical value, we just take this player object and we put it in for the variable. So now we make sure that this player game object that we're using for the positioning information in the script is actually referencing the player object that actually exists in our scene. So that's a direct reference. So now if we just hit play, you can see that our camera moves right along with the player sphere and it doesn't get lost. And I still fall off the board, but I don't, I know when I'm doing it. And so one more thing that we can look at as we're going forward is that there's a button down here in the game view that's called Maximize on Play. And if I hit that, anytime I press play in the game mode, I can actually see my game with the entire Unity window. So then I can actually, I get a better idea of what the game itself is going to look like. So that is our basic rolling sphere setup for our game, and that should give you enough to complete the labs. So I'll let you go, and I'll wish you good luck.